Hello everyone, welcome back to my channel. So in this video we are going to learn about capacitance of coaxial capacitor. Okay, capacitance of coaxial capacitor. If you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. So this is a coaxial capacitor. Okay, so there are positive charges, so there are two circles here, right? So one is inner circle for a cylinder, right? So the inner circle radius is A, so A represents here inner circle radius. Okay, so A represents here inner circle radius. So there are two circles here over the surface of cylinder, right? So inner circle is surrounded by positive charge. So inner circle is surrounded by positive charge. Positive charge, and its radius is A. And outer circle is surrounded by negative charge, and its radius is B. Okay, so B is outer circle radius and it is surrounded by negative charge. So two equal and opposite charges, right? So two equal and opposite charges, that is positive charge and negative charge, and they are separated by some distance in radius, right? So they are different, they are having different radius values, so they are separated by some distance which is change in radius. Okay, so we will have dr here. Okay, so integration is with respect to dr. So they are separated by some distance, so it forms a capacitor. So we have seen the definition of capacitor: two equal and opposite charges. Two equal and opposite charges separated by a distance forms a capacitor. So this is an example of coaxial capacitor. Okay, this is in cylindrical coordinate system, right? So we are going to find the suppose let this be surface 1. Okay, so always positive charge we are considering. So in the previous case also, in parallel plate capacitor also, for positive charge we have considered it as 1, and for negative charge we have considered it as plane 2. Okay, here also I am considering this as plane 1 and this as plane 2. Right, so once you have both planes, then we can find E bar. First of all we have to find E bar, then we have to find potential, and then from potential we can find the capacitance. So capacitance is always given by C is equal to Q by V21. So in order to find V21, we need to find first E bar, that is electric field intensity. Okay, right, see how we are going to find. So we know that from Gauss Law, so phi total, what is Gauss Law? So phi total in mathematical form, phi total is equal to Q enclosed. Phi total is equal to Q enclosed. So integral S d bar dot ds bar is equal to, so Q enclosed. So total charge, let total charge is Q. So Q represents the total charge. Okay, so D, what is D bar? So but D bar is equal to epsilon naught E bar. D bar is equal to epsilon naught E bar. So integral S epsilon naught E bar dot ds bar is equal to Q. So epsilon naught is a constant, you can write outside the integration. So it will become epsilon naught integral S E bar dot ds bar is equal to Q, or integral of S E bar ds bar is equal to Q by epsilon naught. So this epsilon naught I have sent it to right hand side, so it becomes Q by epsilon naught. So E bar integral S ds bar is equal to Q by epsilon naught. Okay, so what is the surface area of cylinder? Surface area of cylinder is 2 pi RH. Okay, surface area of cylinder. Surface area of cylinder is 2 pi r h. 2 pi r h. H is height of cylinder. So here the height of cylinder I have taken it as along the length, because we have taken this in horizontal position, so I have taken that as length here. So height of the cylinder is L. So surface area will become now 2 pi r L. Okay, surface area will become 2 pi r L. So E bar is equal to E bar into, so total surface area will become now 2 pi r L. 2 pi r L is equal to Q by epsilon naught. Right? So therefore E bar is equal to Q by 2 pi epsilon naught r L. Okay, so that total change in electric field intensity is around radius, so we are taking it as AR cap. Okay, so since here we have taken R, we are taking here as R cap, AR cap. If you consider here rho, you can take it as A rho cap. Okay, so the change is with respect to the radius of the cylinder. So we have taken here R, so I have taken here AR cap. Okay, so this is the electric field intensity of the coaxial capacitor. Right, so once we find electric field intensity, we can find the electric potential. Okay, so we have got E bar as Q by 2 pi epsilon naught R L AR cap. Okay, so we have got E bar as this, volt per meter. Right, so next we'll calculate V21. V21 is given by minus integral 2 to 1. Okay, 2 to 1 E bar dot dl bar. Okay, so integral minus 2 to 1. What is E bar? Q by 2 pi epsilon naught RL. Okay, into AR cap dot, what is dl? So dl is change. Okay, so change is along radius. Okay, so change is along radius, so it will be dr AR cap. So dl bar is equal to dr AR cap, because here the change is occurring along radius only. Okay, so height of the cylinder is constant, right? Dz is equal to 0. Okay, so angle also is constant, so d phi is also 0. So change is only with respect to radius, so we will have dl is equal to dr AR cap. Okay, so is equal to minus integral 2 to 1, right? So it will be Q by 2 pi epsilon naught RL into dr. So integration is with respect to radius, so radius of the second sphere, is b. Okay, radius of the second sphere is b here. So in the limits I am changing the limits, so 2 to 1 means radius of the second sphere, because integration is with respect to dr, that is radius. So radius of second sphere is b and radius of first sphere is a. Okay, so it will be Q by 2 pi epsilon naught RL dr. Okay, so all the terms except r in this Q by 2 pi epsilon naught RL are constant, so you can write outside. So V21 is given by Q minus Q by 2 pi epsilon naught L. All these are constants, you can write outside. So integral b to a 1 by r dr. 1 by r dr. Okay, so integration of 1 by x is log x. So how can you take this? Minus Q by 2 pi epsilon naught L into log of r, natural logarithm of r, and the limits are from b to a. Okay, so V21 is minus Q by 2 pi epsilon naught L into, so how can you write this? Log of a minus log of b. Okay, so if you take this minus inside, okay, so inside this bracket, so what you'll get, so you can write it as 2 q by 2 pi epsilon naught L into log of B minus log of A. Okay, so log B minus log A can be written as log of B by A. Okay, so log B minus log A can be written as log of B by A. So finally V21 will now becomes Q by 2 pi epsilon naught L into logarithm of B by A volts. Okay, so this is the formula for potential. This is the formula for potential in the case of coaxial capacitor. This is one of the formula you have to remember. Okay, potential in the case of coaxial capacitor. So what is B here? B is the outer radius, outer circle radius. A is inner circle radius. L is length of the cylinder. Right? So once you got V21, we can calculate the capacitance. C is equal to Q by V21. So it will be Q by 2 pi epsilon naught L into logarithm of B by A. So Q and Q gets cancelled. So C is equal to, so capacitance will become 2 pi epsilon naught, sorry, this is capital L, 2 pi epsilon naught L divided by L natural logarithm of B by A farads. This is one more formula you have to remember. So this is the formula for capacitance in a coaxial capacitor. Okay, capacitance formula for a coaxial capacitor, 2 pi epsilon naught L by natural logarithm of B by A. Okay, so this is how we can find the capacitance of coaxial capacitor, right?